Let's go through the evolution of industry. The story begins with the first industrial revolution in the late 18th century. Steam engines and mechanization transformed manual production into machine driven manufacturing. Industries such as textiles, mining, and transportation experienced unprecedented productivity. The second industrial revolution emerged in the late 19th and early 20th centuries with the widespread use of electricity. Electrification enabled assembly lines, mass production, and standardized manufacturing. This period laid the foundation for modern industrial organizations and global manufacturing systems. The third industrial revolution began in the late 20th century with electronics, computing, and automation. Programmable logic controllers, industrial robots, and computer aided design and manufacturing introduced automated production lines and digital control systems. Manufacturing became more precise, efficient, and scalable. Today, we are living through the fourth industrial revolution, commonly known as Industry 4.0. Industry 4.0 represents the convergence of physical manufacturing systems with digital technologies. Machines, sensors, software systems, and humans are connected through intelligent networks that enable real time data exchange, analysis, and autonomous decision making. Several technological drivers are enabling Industry 4.0. One of the most important is the industrial Internet of Things. Sensors embedded in machines continuously collect data about temperature, vibration, pressure, and operational performance. This data provides real time visibility into production systems. Another key driver is artificial intelligence and machine learning. AI systems can analyze large volumes of industrial data to identify patterns, detect anomalies, and predict failures before they occur. This enables predictive maintenance and intelligent optimization of production processes. Cloud computing and edge computing are also essential components. Cloud platforms provide scalable storage and computing power for analyzing massive industrial datasets. Edge computing allows data processing closer to machines, reducing latency and enabling faster decision making on the factory floor. Digital twins are another powerful concept in Industry 4.0. A digital twin is a virtual representation of a physical asset, machine, or entire factory. Engineers can simulate operations, test design changes, and optimize performance without interrupting real production systems. Advanced robotics and collaborative robots, often called cobots, are transforming manufacturing as well. Unlike traditional industrial robots, cobots are designed to work safely alongside human workers, combining human creativity with robotic precision. Additive manufacturing, also known as 3D printing, is enabling rapid prototyping and decentralized production. Complex components can be produced with minimal waste and shorter development cycles. Augmented reality and virtual reality technologies are also being used for training, maintenance, and remote assistance, allowing engineers to interact with digital models and receive real time guidance while working on physical equipment. The impact of Industry 4.0 extends far beyond individual factories. Production systems are becoming more flexible and adaptive. Manufacturers can shift from mass production to mass customization, producing personalized products while maintaining efficiency. Supply chains are becoming more transparent and connected. Real time data allows companies to track materials, optimize logistics, and respond quickly to disruptions. Predictive maintenance reduces downtime, energy management systems improve sustainability, and intelligent scheduling optimizes resource utilization. However, as industry becomes more automated and data driven, a new question emerges. What should be the role of humans in highly intelligent industrial systems? This question leads us to the next stage of industrial evolution, Industry 5.0. While Industry 4.0 focuses on connectivity, automation, and efficiency, Industry 5.0 emphasizes human-centric innovation. The goal is not just smarter factories, but systems where humans and intelligent machines collaborate effectively. Industry 5.0 is built on three core principles: human centricity, sustainability, and resilience. Human-centric systems place people at the center of industrial design. Engineers focus on technologies that enhance human capabilities rather than simply replacing human labor. Sustainability becomes a central objective. Future industries must reduce waste, minimize environmental impact, and support circular economy models. Resilience is equally important. It is the ability of industrial systems, supply chains to withstand disruptions, adapt to unexpected changes. Industry is no longer just about machines and production lines. It is about intelligent ecosystems where technology, people, and sustainability work together.